If you've ever worked with numbers in Python, I guarantee you've hit this exact problem. You've got a decimal and you need a whole number. Seems simple, right? But how you get there can change absolutely everything. So let's dive in.
Let's just kick things off with a real mystery. You see round 4.5 on your screen and you expect the answer to be 5. I mean, that's what we all learned in school, isn't it? But Python 3 gives you 4. Why? By the end of this, you'll know exactly what's going on.
And this brings us to what I like to call the decimal dilemma. You've basically got two main tools for this in Python, one that forces a number up and another that just finds its nearest neighbor. Knowing which one to pick is absolutely crucial.
So on one side, you have math.ceil. Think of it as this uncompromising optimist. It always looks up. Then on the other side, you've got the built-in round function. It's the pragmatist, just trying to find whatever's closest. Two very different philosophies for handling the same problem.
So let's get to know our first contender a little better. We're going to start with math.ceil, the real specialist of the two, whose entire job is to look in one direction and one direction only, up.
You know, the name itself is a massive clue. Ceil is short for ceiling. And just like the ceiling in a room, this function always pushes a number up to the next highest whole number. It doesn't care about what's fair or what's close, it only cares about what's next.
Okay, one quick but super important detail. Ceil isn't something you can just use whenever. It actually lives inside Python's math module. So before you can use it, you always have to remember to import math right at the top of your script. Don't forget that part. Let's see this thing in action. If you give ceil the number 4.2, you might naturally expect it to go down to 4. It's much closer after all. But ceil doesn't care about that. It sees any decimal at all, and its only job is to go up. So 4.2 becomes 5. And of course, if you give it 4.8, which is already pretty close to 5, it does the exact same thing. It goes up to 5. This consistency is its greatest strength. Whether that decimal is tiny or huge, the result is always the same. Go up.
All right, now this is where things get a little tricky. We get what up means for positive numbers, but what does up mean when we're dealing with negatives? What do you think math.ceil of, say, negative 4.2 is going to be?
And the answer is negative 4. I know, this can feel totally backwards at first. We see a smaller number, 4, instead of 5. But just remember, ceil's one simple rule. It always goes up.
This really helps to visualize the logic. Think about a number line. As you move to the right, numbers get larger or higher. Well, negative 4 is actually to the right of negative 4.2. So to find the ceiling, math.ceil moves to the right, to the next integer up, which is negative 4.
So the bottom line is this. Math.ceil is completely predictable. It's the function you use when you absolutely cannot afford to round down, not even by a little bit. It's always looking for that next highest whole number.
Okay, now let's meet our other tool, the built-in round function. If ceil is that uncompromising specialist, round is the flexible generalist, just trying to find the closest, most reasonable answer.
And its basic logic is exactly what you'd expect. It looks at the decimal. If it's less than 0.5, it rounds down. If it's more than 0.5, it rounds up. Simple, familiar, and hey, no import needed.
So, for a number like 4.2, the function sees that 4 is the nearest neighbor. It's just closer to 4 than it is to 5, so it rounds down. No surprises here.
And for 4.8, the opposite is true. It's much closer to 5, so round takes it up to 5. Again, this is exactly the behavior we learned back in grade school. But we know there's a catch, right? What happens when a number isn't closer to one integer or the other? What happens with 4.5? It's exactly halfway between 4 and 5. This is the tiebreaker scenario, and this is where Python's round function has a very specific and pretty surprising rule.
And here's the secret. Python 3 uses a strategy called round half to even. So instead of always rounding 0.5 up, it rounds to the nearest even integer. This method is sometimes called banker's rounding, and it's used because it's statistically less biased over huge sets of data. It avoids always pushing numbers up.
So now we can solve our initial mystery. When we ask Python to round 4.5, it looks at its two options, 4 and 5. Which one is the even number? 4 is. So that's where it rounds. It's not a bug, it's a very specific, very deliberate feature.
And this just shows you the consistency of the rule.
If we try round 5.5, the options are 5 and 6. This time, the even neighbor is 6, so it rounds up. The rule isn't always round down at 0.5, it's round to the even one.
Okay, so we've met both of our functions. We know their personalities and we know their hidden rules. Now it's time to put them side by side for the final scorecard.
This table sums it up perfectly. With 4.2, CEIL forces it all the way up to 5, while round brings it down to 4. But with 4.8, they both agree and land on 5. This really shows you how round is flexible, while CEIL is just absolute.
So what's the big takeaway? You're going to want to use math.ceil when almost enough isn't good enough. Think about calculating how many buses you need for a field trip. You can't have part of a bus. You always need the next whole one. For most other cases, you'll use round, especially for things like general stats where its unbiased approach is a real benefit. And please, never forget that round half to even rule. It will save you so much confusion.
So you see, the decimal dilemma isn't much of a dilemma once you actually know the rules. It's just about choosing the right tool for the job. Are you going to be an absolutist or a pragmatist? The next time you need to turn a float into an integer, which one will you choose?